Hello everyone. Today in this video I'm going to show you how easy and quick is deploying OpenStack on Baserock. And so first of all I'm going to do a deployment, and then I'm going to explain a few things, and also I'm going to run Tempest and also show you the results. So let's start with the deployment. So yeah, and I'm going to show you what I'm deploying. As you can see in definitions.git, we have some examples of OpenStack deployments. I'm using basically this one, but I've made a few changes. Instead of doing a raw disk deployment, I'm doing a KVM deployment, so it's going to appear here, my virtual machine. I've set the RAM, and I have also modified the host name, and as well I have specified the IP that my virtual machine is going to get. To get more information about this cluster and how you can modify it for your needs, you can see the example. And here you have some information about what you have to do. Also, you will find some information in wiki.baserock.org, guides, OpenStack on Baserock, and here you will find information about deployments, testings, Horizon, Ironic, Zero Meter, and so on. We have as well in definitions.git two other cluster examples for two node deployments, and as you can see you will find some information about it on the morphology, and as well a 3 nodes example. These two examples are going to deploy installer systems. As you can check here, they are deploying installer systems. So with these systems, if you put them in on a USB stick, for example, and you build a machine with it, then OpenStack will be installed in your computer. Also mention that in the two nodes deployment, we combine the cluster, the controller node and the networking node. These three deployments, the example deployments that we have in definitions, are deploying the OpenStack system, which is on systems, OpenStack system. And as you can see, it has a lot of things, but the important strata are the OpenStack Common Stratum, the OpenStack Client Stratum, and OpenStack Services. OpenStack Common is the common dependencies of clients and services, and clients has the clients and services the everything else. And if we take a look at the services, we will see that we have here all the components like Keystone, clans, Nova, Neutron, Ceilometer, and we also have here Tempest, which is not a service, but we install by default Tempest, so you can run it without doing anything else. There might be more things, but anyway. And the deployment should finish soon. Yep, has just finished. So we can now put the machine. But I'm going to do a couple of changes first, which is adding an extra disk. And also I want to modify the MAC address of the network interface. I have it here. Okay, going to put more RAM just in case. Maybe a bit more. And yes, and more CPUs, so that we don't have problems when running virtual machines inside. And now we can put the machine. Okay, why have I changed? Why have I changed the MAC address, and why I have created a disk? The MAC address is so that the system, because as you can see in the cluster morphology, I have set an IP. So putting this MAC address will make my DHCP server give this virtual machine the IP that I wanted to use. And the disk is for Cinder. As you can see as well here, you need a device for Cinder, so that's why I created an extra one. Okay, now the system is running some configuration scripts. I'm going to create a password for it so that we can SSH in. Okay. So to see the progress of this Ansible script, you can either see the journal, or you can see that file. Yeah. Okay. These scripts, these Ansible scripts that it's running, they are in definitions.git as well. If you want to take a look at them, they are in install files, OpenStack user share OpenStack. So all of these YAML files, and there are also some extra files needed for these Ansible scripts in some folders. Okay, once this is finished, I'm going to run Tempest, but running Tempest is going to take too long, more than an hour, so I'm going to show you the results before running the tests. I have them here. For example, we can take a look at the result of the API tests, and we ran 1,114 tests and only 12 of them failed, and which is not bad. And some of them is because we don't have configured VPN as a service or firewall as a service. We are working currently on making all of them pass. We have as well run the client test, no failures, 33 tests. Command tests, which is only one, and service tests, one failure, 26 tests, and I have also run the scenario tests, but I believe we don't have anything configured, so I wonder why they are working. With only 9 failures, 36 tests, and I also run the stress testing, but I think it's just creating one virtual machine. Well, it's 5 tests and they passed. I don't know how well they are, how well it's tested, but anyway, we will make sure that we are more testing to test. I think this has finished. Nothing is being activated, so I am assuming that everything is ready and working. All the OpenStack services are there. So let's go now to configure a bit this system, because for now it only has the admin user and tenant, and if you follow the instructions here, you will get some information about how to configure the network with systemd and create a external network with Neutron and an external subnet with a floating IP allocation pool and some users and tenants and so on. So I have copied these instructions and changed them a bit for my system, and I'm going just to copy and paste it to the system. This is to configure systemd networkd for the network, also to create a external network. And now we can create a demo tenant with its network and create an image and instantiate it. Now, if we go to Horizon, we will be able to log in with the demo user. Sorry. And we will see here soon. Yeah. Okay, it should appear here now. Here it is. And meanwhile, I'm going to show you how to configure Tempest to run the tests. To do that, you have to go to /etc/tempest, and this is not explained in the wiki yet, but it will be soon. To prepare the system to run Tempest, well, first of all, you can run Tempest cleanup that's it. This is going to generate a file here, which is this one, with information of the system, so that you can go back after running Tempest, because it creates a lot of users, tenants, and virtual machines. Now, with this other script, you create whatever is needed for Tempest, to run Tempest. Okay, but there are a couple of things more that we need to add. This will be in the wiki soon, and also we will try to to add these changes that we have to do now manually in the script. But for now, we are going to do it manually. We need also this value. Here. And yep, that's it. We need to modify as well nova.conf, because if we don't, some test will fail. We don't know why yet, but we will try to figure out why. Here you have to put text net, I believe you have to do this as well. We will document this soon in the wiki. Yeah, that's it. The only thing you need to do now is restart Nova API, and yeah, that's it. Before running Tempest, I can show you some things like that. Cinder is Cinder is up and running, or the Neutron agents are running, and Nova has some hosts, and as well I can show you that the virtual machine is there. Okay, this is because I have restarted Nova API. But yeah, as you can see, the virtual machine is running, and you can also get the log from here. Yeah, and I guess that now, yeah, it failed because no API being restarted, but here it is again. And now we can just run the test. And for this example, I'm going to run the API tests -n to use the dependencies that we have installed in the system, and just run it. And we can now see that Tempest is running some tests and they are passing. And that's it. Thanks for watching.